Welcome to section 7.6, static variables and methods. In this lesson, we're going to take a step back and ask, what if there are some values or behaviors that don't belong to a single object, but to the entire class? Here's what you'll learn: how to describe and use static variables, how to define and call static methods, and how the final keyword works with static data, especially when you want to lock values in place. Quick review. Normally, when you want to use an object's fields or methods, you need to instantiate first, right? That gives you a reference to the object. Then you can do things like prisoner p01 assign new prisoner, then p01.name, p01.display, standard stuff, right? But not all classes work that way. Take the math class, for example. You've probably used math.py, math.square root 25. You never had to create a math object, right? That's because these fields and methods are static, meaning they belong to the class, not any one instance. Why does that matter? With regular instance fields, you access them through an object reference, but with static fields, you access them using the class name itself. This isn't just a shortcut. It's a different design approach. Static data belongs to the blueprint, not the object. In exercise 1, play puzzle 811 in Java Puzzle Ball. While you're solving them, pay attention to what happens when you rotate the blue wheel. How does that affect the bumpers? What's being shared versus what's individual? Then we'll talk about what's really happening behind the scenes. Let's debrief. In those puzzles, rotating the blue wheel changes the orientation of all blue bumpers. That's because the orientation is shared. It's a static variable. On the other hand, when a bumper is struck, only that bumper's rotation changes. That is an instance variable. So here is a difference. Static variables are shared across all instances of a class. You only need to change the static variable once, and every object sees the new value. Perfect for something like orientation on all bumpers. Even if you haven't created any objects yet, you can still access static variables. So in puzzle 11, the blue wheel can rotate and update the orientation of blue bumpers, even if there aren't any blue bumpers present to show it. Pretty cool. But what about instance variables? They are totally different. Each object gets its own copy. If you want to change the rotation of one red bumper, you need to target that specific instance. So when should you make something static? Ask yourself, is this value shared by every object? Does it describe the class more than any specific instance? Will you need it even before any object exists? Is it a constant used in calculations? If yes, go static. To make a variable static, public static int orientation assign 45. Now, every object of the class shares that one variable. Important tip: initialize the static variables right away. Otherwise, constructors might accidentally overwrite the same static field multiple times. Inside a class, static variables are easy to access. No object needed. In a method like public void display, inside the body, system.outprintln orientation, system.outprintln rotation, you can use both. It's no problem. The first one is static, the second one is instance. But outside the class, you have to reference the class name. How? Red bumper dot orientation. This works even if you have never created a red bumper object. In exercise 2, let's jump back to our prison test project. In the prisoner class, add a static field called prisoner count. Initialize it to 0. Incremented every time a prisoner is created. Also add a booking number field, which is instance field, and assign it to the current value of prisoner count in the constructor. Finally, update display to print both. This works because prisoner count tracks how many prisoners have been created across the entire program, not just for one project, one object. That's a classic use of static data. Now let's talk methods. So far, most methods you've written are instance methods. But just like variables, methods can also be static. Why make a method static? 1. If it only uses static data. 2. If it doesn't rely on any one object. 3. If it needs to run before any object exists. To declare one, public static void display prisoner count inside system.out.println prisoner count. Now, you can code it from anywhere, including without a prisoner object. Inside the class, both instance and static methods can call a static method, like public void show info inside the body, display prisoner count. Outside the class, you use the class name, prisoner.display prisoner count. No object needed. In exercise 3, encapsulate prisoner count, make it private, add a getter method, public static int get prisoner count, then try making the display method static. Your IDE might not be happy with that last one, and that's good. Why the complaints? Because a static method can't use instance data. Booking number only exists for actual object. If display is static, there is no object, so no booking number. This is Java protecting you from yourself. Static variables are variables that are shared by all instances of a class. Example, a variable that's a counter that will increment each time an instance of a class is created. Static final variables are variables that are shared by all instances of the class, but the value cannot change. For example, interest rates or tax rates remain constant for all instances of the class. This can also be accessed without creating an instance of the class and should also be public. So here is the rule. Static methods only touch static stuff. Instance methods can access both static and instance stuff. Mixing that up creates problems and the compiler will stop you. One more tool, the static final field. This is great for constants. Things like maximum values, tax rates, interest rates. Stuff that never changes but gets reused. For example, public static final int max prisoner count 100. By convention, constants are written in all caps. Use underscores for spaces. You can even make static final fields public, like public static final double pi assigned 0.14159. No getter needed. Since the value can't be changed, there is no risk in exposing it directly. That is why math.py and math.e are accessible like system.out.println math.py. To wrap up, static variables and methods belong to the class, not instances. Use them for shared data, constants, and pre-object logic. Static variables are great for counters, limits, or class-wide states. Static methods are tools, often utility-based or for accessing static values. Use final when you want to lock in a value, and use naming conventions for clarity.